Alright, in this example we're going to be finding the modulus of z, okay, given that 5 times the modulus of z minus 1 equals the modulus of z minus 25, where z is a complex number. Alright, so let's think about what we have to do here. Normally, if I was doing algebra, regular algebra, you'd expect to distribute this 5 and you'd think it'd be pretty simple, but we're talking about complex numbers here, and properties of complex numbers needs to come into play here. So let's start with 5z minus 1. Let's just start with the problem. Okay, so here's my problem. I need to somehow get rid of these and get it these absolute value signs, this modulus symbol, and get it so that it's just around the z. Okay, how do I do that? Well, this is a little technique that we're going to be using. Okay, what you have to do here is you have to use this property. If I were to take a modulus symbol and square it, okay, the complex number on the inside becomes, the modulus sign disappears, and we can take the complex number inside and multiply it by the conjugate of that complex number. Okay, so this is one of the properties that we'll be using for this. Okay. And we'll look at another property that we're going to need for this as well. Okay, so let's see, what can I do here to get rid of this now? Okay, so I pretty much have these two separately, so I need to square both sides basically. Okay, so if I square both sides, this is what I get. Okay, z minus 25 squared. All right, and now what happens to this term here? This becomes 25. Okay, since we know that the inside part stays the same, okay, since we have z, okay, this inside part stays the same, and I multiply it by the conjugate of that inside part. All right, and then this part over here, this becomes, whoops, that becomes, since that's the modulus of this number squared, we have that number times its conjugate. Okay, and notice here that I'm not saying z plus 25, okay, because this is actually two numbers being added together. Okay, and I have a quantity that's being conjugated. Okay, so now how do I deal with this part? So I guess I've isolated this. But how do I deal with this part? Okay, well, you have to think back to your properties of conjugates. If I have z minus w and I conjugate it, can I simplify this? Yes, this conjugation distributes across this arithmetic operation, and we end up with z star minus w star. Okay, so this is again a property that you need to know. Okay, so you need to be familiar with your conjugate properties and your modulus properties. So let's simplify. This becomes 25 times z minus 1. This is z minus 1 conjugated, so that becomes z star minus 1 star. But what's 1? 1 is just a real number. Is there a conjugate for a real number that has no imaginary part? No, it's the same number. So we just say minus 1. Okay, same thing over here. Z minus 25 stays the same. The conjugate of z minus 25 becomes z star minus 25's conjugate is just 25. Okay, so now we have a simplified, now we have something that we can work with. We can start isolating our z and z stars. So you can see here we're probably going to need to use this again to get our z modulus of z back. So I'm going to try and get these terms to come together and isolate them, and then substitute with that. Okay, so we end up with, if I expand everything out here, okay, I would get 25. Let's see, 25 times z star. Okay, minus z star minus z plus 1, and this side would become z times z star minus 25z star minus 25z, and it's 25 times 25 is 625, and those are both negative, so that'd be 625. Okay, 25 distributed across here leaves me with 25z star minus 25z star minus 25z plus 25, and the side stays the same. Okay, so now I've expanded everything, and now I can start simplifying. Okay, so if I start simplifying, then you can see that minus 25z star, these would cancel. Minus 25z's would cancel, and I'm left with 25z. Let's move everything over. Let's move the z star terms over here and the 25 over here. So we're left with 24z star equals 625 minus 25. That's 600. Okay. And if I divide both sides by 24, I believe I will get 25. Okay, so this is very convenient. Okay, now that we have z star, we can replace it with the magnitude of z squared, right? And once I have this, I can take the square root of both sides, and the z becomes 5. Normally you'd think it'd be plus or minus 5, but since this is a magnitude and this is a distance, the positive value is the only one that we take into account. Okay, so the magnitude of any number, complex number, must be greater than 0. Okay, so that's my answer. I found the complex number, the magnitude of the complex number z.